Welcome, stargazers, to another soothing journey with the sleepy astronomer. Tonight, as you drift among the stars, we ask a question that has fascinated humanity for centuries. How big is the universe? Before we begin, I'd love to know, where in the world are you watching from tonight? Whether you're wrapped in a warm blanket in Norway, gazing up at the stars in South Africa, or winding down in a cozy apartment in Japan, this space is for you. Let's leave the stress of Earth behind and float together into the vastness of the cosmos. Now, close your eyes if you'd like. Let your breathing slow. And let's begin. We begin our journey under the quiet majesty of the night sky. Imagine yourself lying back in a soft field, the cool air brushing gently against your skin as the stars begin to blink into view above you. The sun has long set, and the world has hushed, leaving only the distant rustle of wind through leaves and the rhythmic beat of your breath. As your eyes adjust to the darkness, the sky transforms from a flat black canvas to a deep, shimmering ocean of light. Stars emerge one by one, some bright and steady, others faint and trembling, each a silent witness to the history of the universe. To gaze upward is to see not just points of light, but ancient messages from deep time. The light from even the nearest stars has travelled years to reach your eyes. Some of the stars you're seeing tonight may have already burned out, their light still journeying across the vast emptiness of space. What we witness is the past, painted across the heavens. There's something indescribably calming about the stars. They ask nothing of you. They don't rush. They simply exist, patient, eternal, distant, and in their silence, they invite your own quietness. As your thoughts begin to slow and your breathing deepens, you may notice how the stars seem to form patterns, constellations that ancient civilizations once traced with stories. People long before us looked up at the same sky, wondering the same things. What are those lights? How far away are they? What lies beyond them? But for now, there is no need to think too hard. Just feel it. The night sky holds you in its gentle embrace. High above, the Milky Way stretches across the sky like a soft river of dust and light, a reminder that we are inside something so much greater than ourselves. It's easy to forget during the day that we are part of something enormous. But at night, when the sky opens up, we are reminded of our place within the cosmos. A small place, yes, but a place nonetheless. You might begin to notice the rhythm of the stars. Though they appear still, the earth is spinning ever so slowly beneath you. The stars are drifting, inching across the sky with every passing moment. Time feels different here, suspended, slower, softer, more forgiving. The worries of the day begin to melt away, replaced by a sense of quiet awe. Above you, perhaps you notice a single bright point moving steadily across the sky. It might be a satellite, silently circling our planet. A reminder that even in this stillness, we are explorers. Even now, our machines orbit above us, peering further into space than our eyes ever could. But none of that feels urgent tonight. Tonight, you are simply a being of breath and presence, lying under an ancient sky. Even if clouds roll in, soft and silver in the moonlight, hiding the stars from view, the universe is still there, still vast, still humming in the background, still waiting. It doesn't mind if you close your eyes. It doesn't mind if you drift away. It will be there when you return, silent, beautiful, and impossibly big. So breathe slowly. Feel your body relax into the earth. Let the stars, visible or hidden, remind you that you are safe, and small, and infinite all at once. The sky above you is more than sky. It's a door, and tonight we're going to walk through it together. Let's begin our journey a little closer to home, drifting down from the stars and into the quiet cradle of our cosmic neighborhood. Picture Earth, our little blue world, suspended in the gentle darkness of space, wrapped in a thin veil of atmosphere. Its surface shimmering with oceans, forests, deserts, and clouds. From space, Earth looks calm and delicate. There are no borders here, no cities visible from this distance, no noise, only a spinning sphere of life, floating silently in the cosmic sea. We are part of something far greater than we usually remember. Earth is just one planet in a family of worlds that orbit a star we call the Sun. This family, the solar system, is like a small village nestled deep within a vast and ancient forest. It includes rocky neighbours like Mercury, Venus and Mars, majestic giants like Jupiter and Saturn, and icy wanderers like Uranus and Neptune. Each one has its own story, its own character, its own strange and beautiful surface that has never known the touch of human feet. And yet, as varied as these planets are, they all move together in a graceful celestial dance, held in place by the invisible threads of gravity. Around the Sun they orbit, endlessly, silently, predictably, just as they have for billions of years. The Sun, at the centre of it all, burns with a steady golden light. It is a massive ball of hydrogen and helium, so powerful that it provides warmth and energy to everything in the solar system. It seems ordinary from our perspective, but the Sun is actually a star, a perfectly average one by cosmic standards. Yet it is so large that it makes up more than 99% of the mass of our entire planetary system. Our Earth, third from the Sun, orbits at just the right distance for life to thrive. It is a miracle of balance, not too hot, not too cold. Here, water flows freely, trees reach toward the sky, animals roam, rivers carve valleys, winds sweep across great plains. And somewhere, in the quiet hours of the night, people like you are looking up, wondering about the universe and their place within it. But the solar system doesn't end with Neptune. Beyond the outer planets, there lies a mysterious region called the Kuiper Belt, home to dwarf planets like Pluto, and countless icy objects that drift through space like ancient relics from the early days of creation. Farther still, there's the Oort cloud, a distant spherical shell of icy bodies that may extend a light year from the Sun. These edges of the solar system are barely understood, but they form the boundary between what we call our home and the greater universe beyond. If we were to zoom out even more, we'd see that our solar system is not floating in isolation. It's nestled inside a vast spiral galaxy called the Milky Way. The Milky Way is made up of hundreds of billions of stars, each with its own planets, moons, and mysteries. Our Sun is just one of these stars, one tiny point of light among countless others, located in one of the galaxy's spiral arms, like a single house on a street in a city beyond imagining. It's humbling to realise that, even with all our telescopes and satellites, we've only explored a tiny corner of our own neighbourhood. We visited the moon. We've sent robotic eyes to Mars, Venus, and the outer planets. We've even sent a spacecraft, Voyager 1, beyond the reach of the sun's influence, into interstellar space. But in cosmic terms, we've barely stepped out the front door. And yet, we are learning. We are observing. We are dreaming. Every discovery we make about our solar system helps us understand more about ourselves, our origins, our future, our place in the grand scheme of things. The Earth is not the centre of the universe. The Sun is not the biggest star. Our galaxy is not the only galaxy. But somehow, from this one tiny planet, life emerged, became conscious, and began asking questions. So as you rest tonight, know that you are part of a magnificent structure, an intricate web of celestial bodies, forces and rhythms that stretch out in all directions. Your breath, your heartbeat, your thoughts, they are all happening on a planet that spins at 1,000 miles per hour, orbits the Sun at 67,000 miles per hour, and journeys with the Sun through the galaxy at nearly 500,000 miles per hour. And yet, here you are, still and safe, floating with it all. Let the knowledge of this vast system bring you comfort, not fear. You belong to a cosmic family, intimate and immense, and everything you see, hear, and feel is part of that wondrous dance. Earth is your home, yes, but it is also your ship, your island, your sanctuary in the stars, and it is carrying you gently through a universe that is far bigger and more beautiful than you've ever imagined. When we ask how big the universe is, we immediately run into a challenge. How do we even begin to measure something so vast, so expansive, that it stretches beyond anything we can see or touch? The distances between stars, galaxies, and cosmic structures are so immense that ordinary units, like kilometers or miles, quickly become useless. Imagine trying to describe the distance between two cities on Earth using millimeters. That's how unhelpful miles become when trying to measure space. Astronomers needed something bigger, something more fitting. So they turned to one of the universe's own natural yardsticks, light. Light is the fastest thing we know. It travels at about 186,000 miles per second, or roughly 300,000 kilometers per second. In just 1 second, a beam of light could circle the Earth more than 7 times. But space isn't measured in seconds. Space is patient, deep, almost eternal. And so we measure distance in terms of how far light can travel over time. That's where we get the term light year. A light year is not a measurement of time, but a measurement of distance. It is the distance that light travels in a vacuum in 1 Earth year. That's about 5.88 trillion miles, or roughly 9.46 trillion kilometers. When we say a star is 4 light years away, like Proxima Centauri, our closest stellar neighbour, it means the light you see from that star tonight actually left it 4 years ago. You're not seeing the star as it is now, but as it was when its light began the long journey to your eyes. This way of seeing the universe, through the lens of time, as well as space, is one of the most poetic aspects of astronomy. Every glance into the night sky is a look into the past. Some of the stars you see might not even exist anymore. They may have gone dark long ago, but their light is still en route, still travelling, still telling their story. As we explore further out, the distances quickly become mind-bending. The Milky Way, our galaxy, is about 100,000 light years across. That means if you could ride a beam of light, it would still take you 100,000 years to cross from one end of our galaxy to the other. And remember, our galaxy is just one among an estimated 2 trillion others in the observable universe. To cope with these extreme distances, astronomers also use smaller units like astronomical units, or AUs. 1 AU is the average distance between the Earth and the Sun, about 93 million miles or 150 million kilometers. This helps us measure distances within our solar system. For example, Mars is about 1.5 AUs from the Sun, while Neptune is nearly 30 AUs away. But once we leave the solar system behind, even AUs begin to feel tiny and inadequate. Another unit, the parsec, is commonly used in professional astronomy. 1 parsec equals about 3.26 light years. You might have heard it in science fiction, like in Star Wars, though it's often misused there. The word comes from parallax of 1 arc second, and is based on the way nearby stars appear to shift position relative to distant ones as Earth orbits the Sun. It's a clever bit of cosmic triangulation, using geometry to measure distances to stars without ever having to leave Earth. But no matter which unit we use, whether it's light years, parsecs, or AUs, the truth is the same. We are small, and the universe is unfathomably large. The numbers become so vast that our minds start to blur them into abstract symbols. A billion, a trillion, a light year, a parsec. They become like raindrops in an ocean too deep to measure. Yet even within this overwhelming scale, there is beauty. There is meaning, because these measurements are not just numbers, they are the keys to understanding our place in the cosmos. They allow us to map the heavens, to trace the paths of comets, to estimate the age of galaxies, and to peer back in time toward the birth of stars and even the universe itself. And perhaps most beautifully, they allow us to share a kind of connection with the cosmos. When you look at a star and know that its light has been travelling for hundreds, thousands, or even millions of years to reach you, there's something magical about that. It's as if the universe has been whispering across the ages just for you to listen. So when we measure the universe, we're not just calculating distances, we're tracing the threads that connect us to everything else. We're saying, I see you, star. I know how far you are. And still, your light has found me here. In a universe so vast that even light takes millions of years to travel from place to place, that connection becomes something sacred, something profound. So breathe deeply, let the vastness wash over you, not as something frightening, but as something deeply comforting. In this boundless ancient cosmos, we found a way to measure the immeasurable, to give shape to the infinite. And from our small corner of space, we reach out quietly, gently, with hearts full of wonder. Imagine standing at the edge of a vast field, stretching so far into the distance that you can't see where it ends. Now imagine that field is not a field at all, but the universe itself, filled with stars, galaxies, and ancient light. This is what astronomers call the observable universe, the part of the cosmos we can see explore, and study using the tools of modern science. But what does observable really mean? And why is it limited? To understand this, we need to go back in time, about 13.8 billion years ago, to the moment of the Big Bang. This wasn't an explosion in the traditional sense, but rather the sudden and rapid expansion of space itself from an unimaginably hot and dense point. From that moment forward, space has been growing, stretching, evolving, galaxies formed, stars were born, planets began to spin around suns, and the universe began to cool and expand even as it continued to fill with light. But here's the key. Light travels at a finite speed. Even though it's the fastest thing in the universe, it still takes time for light to reach us. When you look at the moon, you're seeing it as it was about 1.3 seconds ago. When you look at the sun, you're seeing it as it was 8 minutes ago. And when you look at the farthest galaxies we've ever detected, you're seeing them as they were billions of years in the past. The observable universe is defined by this very idea. It's the region of space from which light has had enough time since the Big Bang to reach us. That light has been travelling for billions of years, moving through the fabric of expanding space, and finally arriving at our telescopes, our satellites, and even our eyes. From our vantage point here on Earth, we can see about 46.5 billion light years in every direction. That forms a sphere. Imagine it like a glowing, invisible bubble centered on our planet, roughly 93 billion light years in diameter. Within this sphere lie all the galaxies, stars, nebulae, and cosmic phenomena we've ever observed. Trillions of celestial bodies, each with their own stories, each with their own light that's been travelling through the darkness for eons. And yet, this is only what we can see. The real universe may be far, far bigger, possibly infinite. The observable universe is not the entire universe, any more than a candle in a dark cave is the entire cave. It's just the part illuminated by the light that's reached us. It's easy to assume that the edge of the observable universe is like a wall or a boundary, but it's not. There's no border, no physical line we could cross. Instead, it's a limit set by time and light. Beyond that edge, there are likely countless galaxies and stars we'll never see, simply because their light hasn't had time to reach us yet, and may never reach us, especially if the universe continues expanding at an accelerated pace. What's more, because of this expansion, many of the galaxies we observe now are already moving away from us faster than the speed of light. Not because they are speeding through space, but because space itself is stretching between us and them. That means even though we can see them now, their light will eventually stop reaching us. Over time, the universe will appear darker and lonelier, not because there's less in it, but because more and more of it is slipping out of our view. Think about that for a moment. There are entire galaxies, entire civilizations perhaps, whose light has not yet arrived, and may never arrive. There could be wonders beyond imagination. Galaxies made of strange matter, stars in colours we've never seen, or even phenomena we don't yet have names for. And all of it is out there, just beyond the edge of what we can observe. But within our cosmic bubble, the beauty is still staggering. There are galaxies shaped like spirals, like eggs, like colliding rivers of stardust. There are quasars, brilliant beacons powered by supermassive black holes, shining across billions of light years. There are stars being born in glowing nurseries of gas and dust. And there are remnants of the early universe itself, faint, ancient light still echoing through the cosmos, known as the cosmic microwave background. This whisper of radiation is the universe's baby photo. What it looked like just 380,000 years after the Big Bang. It wraps around us in all directions, the oldest light we can detect, and perhaps the most profound. Even though the observable universe is limited, it is still almost beyond comprehension. It contains about 2 trillion galaxies, each with billions or trillions of stars. That means there are more stars in the observable universe than grains of sand on all the beaches of Earth. And around many of those stars there are planets, some hot, some cold, some small, some vast. Some may be lifeless, some may hold oceans, and some, just maybe, might look up at their skies and wonder, just as we do. In the quiet hours of night, when you gaze up at the stars, remember that you are looking out across a vast, ancient, and ever-expanding sphere of possibility. Every twinkle is a time traveller. Every glow is a message from the distant past. And while we may be small, our ability to see, to ask, to wonder, that is what connects us to the cosmos. So let your thoughts drift outward, past the planets, past the stars, beyond the farthest galaxies, to the invisible edge of what we can know. And rest in the knowledge that even in our smallness, we are part of something immeasurably grand. The observable universe is not just a boundary, it is a window. And tonight, it is open just wide enough for your dreams to float through. Imagine the universe as a great ocean, vast, dark, and seemingly endless. For a long time we thought of it as something fixed and still, like a painting on the wall of reality. But then we discovered something astonishing. The universe is not standing still. It's growing, stretching, expanding in all directions, every moment of every day. Space itself, the very fabric of the cosmos, is moving like the surface of rising dough or the inflating skin of a balloon. And everything within it, every galaxy, every star, every planet, is drifting along with it. This discovery was one of the most profound moments in the history of science. In the early 20th century, astronomer Edwin Hubble noticed something strange. When he studied the light from distant galaxies, he found that it was redshifted, meaning the wavelengths were stretched, shifted toward the red end of the spectrum. This wasn't just a quirk of physics, it was a message from the cosmos itself. It told us that these galaxies were moving away from us, and not just a few of them, all of them. The farther away a galaxy was, the faster it seemed to be receding. This led to a radical and beautiful realization. The universe is expanding, and it has been ever since the moment it began. But it gets even more fascinating. The expansion of the universe doesn't mean galaxies are speeding through space like cosmic rockets. Instead, space itself is expanding, carrying galaxies along like corks drifting apart in a rising tide. Picture tiny dots drawn on the surface of a balloon. As you blow the balloon up, the dots move away from each other, not because they're moving on their own, but because the surface itself is stretching. That's what's happening to the universe. This expansion is everywhere. It happens in the vast gulfs between galaxies. It happens in the great voids that lie between clusters of galaxies. Even the empty space in front of you, in the room where you're resting right now, is part of this grand stretching, though at a scale far too small for us to detect in everyday life. Only across the vastness of intergalactic space does the expansion become noticeable. What's even more mysterious is that this expansion isn't slowing down, it's speeding up. This discovery shocked scientists when it was confirmed in the late 1990s. Using distant supernovae as cosmic mile markers, astronomers realized that galaxies weren't just drifting apart, they were being accelerated away from one another by some unseen force. They called it dark energy, and to this day, we don't fully understand what it is. Dark energy now makes up about 70% of the entire energy content of the universe. It's invisible. It doesn't shine, reflect, or give off any light, but it exerts a pressure that stretches space itself faster and faster over time. This means that the universe's expansion will not stop. It will not reverse. It will continue, pushing galaxies so far apart that one day most of them will vanish from view. This paints a strange and poetic picture of the far future. Right now, our night sky is filled with stars and galaxies. But trillions of years from now, a future observer on some distant world might look up and see only darkness. The stars we see tonight will have faded. The galaxies we study now will have drifted so far away that their light will never reach us again. The universe will seem smaller, not because it is, but because so much of it will lie beyond the horizon of what can ever be seen. And yet, there is something profoundly peaceful in this. The universe is not chaotic or random. It follows rhythms and laws, patterns of expansion and flow that are deeply consistent. The same physics that moves galaxies across billions of light years also governs the falling of a leaf, the orbit of a moon, the heartbeat in your chest. You are not separate from the universe's expansion. You are part of it. You are riding the wave, gently carried along with everything else. Even our own galaxy, the Milky Way, is not immune to cosmic motion. Though nearby galaxies are drawn together by gravity and may eventually collide with us, like the Andromeda Galaxy, which is on a slow-motion collision course with our own, the overall expansion of the universe continues around them. These localized mergers are like raindrops joining in a puddle, even as the whole world moves beneath them. If you were to fast forward time billions of years into the future, you would watch the cosmic web stretch and thin. Galaxies would slip out of view. Stars would die. Black holes would slowly evaporate. And space would become colder, quieter, darker. This is known as the heat death of the universe, or the Big Freeze, a state where expansion has carried everything so far apart that energy can no longer flow, and the cosmos reaches a final, silent stillness. And yet, here you are, alive, breathing, thinking, at a moment when the universe is still filled with light, when the stars still shine, when the galaxies still whisper across space with their glowing arms and their radiant hearts. You exist in a golden age of cosmic visibility, a time when we can still look into the deep sky and see the remnants of the beginning, the threads of time stretching back billions of years. so let this bring you comfort. The universe is not a cold machine. It is a living, breathing tapestry. And it is still expanding, not into something, but into itself, unfolding its own potential like a story still being written. Every second, every breath, every heartbeat is part of that unfolding. You are not a passive observer in all this. You are woven into the very fabric of this expanding cosmos. As you lie in quiet reflection, know that the same forces that stretch the galaxies apart also stretch time itself, gently, rhythmically, endlessly, like a lullaby sung in the dark. Let that rhythm soothe you, carry you, and lull you into peaceful sleep. The universe is growing, and you're growing with it. Beyond everything we can see, past the glowing stars, the swirling galaxies, and the quiet hum of cosmic light, there lies something even more mysterious. The part of the universe we cannot see. It's not hidden behind clouds or darkness. It's not invisible because it's too small or too dim. It's invisible because its light hasn't reached us yet. And perhaps it never will. This boundary is not made of walls or fences. It's made of time. Light travels fast, faster than anything else in the universe. But even light needs time to move through space. And since the universe has only existed for about 13.8 billion years, that's the maximum time light has had to travel. The farthest things we can see are the things whose light has taken all that time to arrive. Beyond that distance, light simply hasn't had enough time to reach us yet. Imagine standing in a vast field, waiting for distant fireworks to appear on the horizon. You know they've been set off. You can hear the echoes, maybe even see a faint glow. But the fireworks themselves are just too far away. Their light hasn't arrived. That's what exists beyond the observable universe. A realm full of stars, galaxies, and possibly entire structures larger than anything we know, all existing just out of reach. We call this region the unobservable universe. And it is a place of wonder, silence, and the purest form of mystery. The strange part is that, in theory, this region could be infinitely large. Our observable universe might be just a tiny bubble in an ocean of reality. There could be billions, trillions of galaxies beyond our cosmic horizon. Some might look just like ours. Others might be completely alien. And beyond even those could be regions of the universe that obey entirely different physical laws, where gravity behaves differently, or where time itself flows in unfamiliar ways. This brings us to a haunting truth. We may never know how big the universe truly is. No matter how powerful our telescopes become, no matter how far we stretch our minds and our math, there will always be a limit, defined not by technology, but by the fundamental nature of space and time. The edge of the observable universe is like a cosmic mirage. We can approach it, but we cannot pass beyond it. We cannot see what lies behind the veil of the lightless unknown. Some scientists believe that the universe extends far, far beyond this edge, and that it looks more or less the same as what we can see. This idea is based on something called the cosmological principle, the assumption that on a large enough scale, the universe is roughly uniform. That is, if you could zoom out far enough, so far that entire galaxies look like dust particles, then no matter where you were, the universe would look more or less the same, smooth, balanced, infinite. But others go even further. They wonder, what if the unobservable universe isn't just more of the same, but something completely different? What if it contains other regions with entirely different histories? What if there are other pocket universes branching off like bubbles in a cosmic foam, each with its own rules, particles and physics? This idea is known as the multiverse, and though it sounds like science fiction, it is taken seriously by many physicists who study the early moments after the Big Bang. In this view, our entire observable universe might be one bubble in a sea of bubbles, an island of stars floating in an endless archipelago of realities. And beyond each of those, we simply don't know. We may never know, but mystery doesn't mean emptiness. Just because we can't see what's beyond doesn't mean it isn't full of beauty or meaning or life. The light from those places hasn't reached us, but that doesn't mean it never existed. The universe beyond the edge may be singing its own quiet song, one we'll never hear, but that still echoes softly through the vast silence of space. And this brings a strange kind of comfort. We often want to grasp everything, to measure it, map it, name it. But some things are meant to remain open-ended. The size of the universe may be one of them. It invites us to let go of certainty, to rest in the unknown, and to appreciate the breathtaking scope of what we can see. As you lie quietly beneath the stars, try to imagine that unseen expanse. Not in fear, but in peace. Know that beyond the black velvet sky, there is more. More stars, more galaxies, more moments of creation blooming in darkness. It is a realm of possibility, of gentle potential, of a universe that is always just a little bigger than our minds can hold. So let yourself drift there, past the edge of sight, past the farthest galaxies, past even the echo of the Big Bang. Let your thoughts expand beyond the limits of light, into the vast beyond that has never been touched by human eyes. Float there, weightless and calm, in the great ocean of the unknown. The universe may be larger than we will ever understand, but in that vastness, you are still here, still breathing, still part of it all, and perhaps that's the most beautiful mystery of all. In the quiet of space, beyond the reach of noise and the pull of gravity, there drifts an overwhelming truth. The universe is full of galaxies. Not dozens, not hundreds, not even millions, but trillions. Each one a vast city of stars, scattered across the universe like glowing islands in a dark cosmic sea. For much of human history, we thought our galaxy, the Milky Way, was the entire universe. When people looked up at the night sky, they imagined all the stars they saw belonged to a single great system, a complete and self-contained cosmos. It wasn't until the 20th century that this illusion was broken, in one of the most profound shifts in human understanding. In the 1920s, using a telescope atop Mount Wilson in California, Edwin Hubble peered into the spiral-shaped smudges once thought to be clouds of gas within the Milky Way. What he discovered changed everything. These smudges were not clouds at all, but entire galaxies in their own right, each one home to billions of stars, and each separated from us by unimaginable distances. That discovery opened a door that has never closed. As our instruments grew more powerful, so did our understanding of the cosmos. From telescopes on mountaintops to those orbiting Earth like the Hubble Space Telescope, we began to scan the sky with greater clarity and depth. And what we saw was nothing short of staggering. The more we looked, the more we found. The early estimates of a few million galaxies gave way to tens of billions, then hundreds of billions, and now, thanks to deep field observations, we estimate that the observable universe contains about 2 trillion galaxies. Let that number settle in your mind for a moment. 2 trillion separate galaxies, each massive, rotating collection of stars, gas, dust, and dark matter. If each of those galaxies held just 100 billion stars, and many contain far more, that means the universe might contain more stars than there are grains of sand on all the beaches of Earth. And those stars are not just floating aimlessly in space. Around many of them, planets orbit. Some are scorched and airless. Others are gas giants, frozen spheres, or molten wastelands. But among them, statistically speaking, some must be like Earth. Some must harbour warmth, oceans, weather, perhaps even life. Galaxies themselves come in a variety of shapes and sizes. Some are elegant spirals, like our own Milky Way, with arms stretching out in grand pinwheels of starlight. Others are elliptical, like soft, glowing orbs of stars, lacking any particular shape. Still others are irregular, distorted by collisions or interactions with neighbouring galaxies, twisted forms that resemble scattered clouds or crashing waves. Each galaxy contains its own internal dramas. Stars are born in vast nurseries of gas and dust, ignite with nuclear fire, live out their luminous lives, and then fade away, sometimes gently, sometimes violently, in brilliant supernova explosions. These explosions send elements into space: carbon, oxygen, iron, the very building blocks of planets and people. Those elements are swept into new clouds, which birth new stars, in a never-ending cycle of cosmic renewal. At the heart of most galaxies lies something even more mysterious: a supermassive black hole. These giants, millions or even billions of times the mass of our Sun, shape the evolution of their host galaxies. Some lie quietly, while others rage with energy, pulling in gas and dust and unleashing powerful jets of radiation that can be seen across the universe. They are both destroyers and creators, silently influencing the rhythm of star formation and the structure of the galaxy itself. Galaxies are not solitary travellers either. They often exist in clusters, bound together by gravity in immense structures. These clusters can contain hundreds or thousands of galaxies, swirling around a common centre, connected by filaments of dark matter. Together, they form the cosmic web, a delicate, sprawling structure that fills the universe, with galaxies tracing the outlines of invisible threads, like dew on a spider's web stretched across all of space. And still, we've only seen a fraction of what's out there. Our deepest observations, like those from the James Webb Space Telescope, have only begun to peel back the layers of time and distance. When we look into space, we're also looking into the past. The light from the most distant galaxies has been travelling for over 13 billion years. Some of the galaxies we see in those ancient images no longer exist as they were. Their light is a fossil, a memory captured in photons, finally arriving at our eyes after a journey of cosmic proportions. That's the beautiful paradox of astronomy. Every new discovery reminds us not just of what we know, but of how much more there is to uncover. Every galaxy is a story, a history, a set of physical laws expressing themselves in brilliant and varied ways. Some galaxies are massive and teeming with new stars. Others are quiet and old, filled with ancient suns on the verge of fading away. Some collide and merge, creating bursts of star formation. Others drift alone in the darkness, isolated and still. And here we are, on a quiet little planet, orbiting a quiet little star, in one small corner of one galaxy among trillions. And yet, from this small perch, we have learned to see the galaxies, to measure their light, to understand their motion, and to dream about what might exist in their distant corners. So the next time you look up at the night sky and see just a handful of stars, remember, the real show is beyond what the eye can see. You are looking out into a universe filled with galaxies beyond number, each one spinning, each one glowing, each one participating in a vast and ancient dance across the endless dark. Let your mind drift there, past the limits of our own Milky Way, past the local group of galaxies, out into the web of cosmic filaments, where countless other galaxies shine softly in the dark. You don't have to understand all the physics. Just know that it's happening, that you are part of it, that your atoms were forged in stars, and that your breath, your thoughts, your dreams are all made possible by the quiet work of galaxies. And in that knowing, find peace. The universe is vast, but it is not empty. It is filled with light, more light than you will ever see. And each little glimmer is a reminder that you are not alone. You belong to something greater. You belong to the stars. The stars are what first draw our gaze when we look up at the night sky. Tiny points of light, scattered across the darkness like delicate jewels. But if you stare long enough, you begin to realize not all stars are the same. Some shine brightly, others flicker gently. Some have a bluish hue, while others glow a softer orange. What you will seeing are not just distant suns, but a wide variety of celestial giants, objects so vast and powerful that they defy ordinary understanding. To begin to grasp the true scale of the universe, we must first come to terms with the scale of its most abundant and awe-inspiring inhabitants, the stars. Let's begin with something familiar, our own star, the Sun. It is, by every human measure, colossal, a sphere of glowing plasma more than 100 times the diameter of Earth. If it were hollow, over 1 million Earths could fit inside it. Its surface burns at around 5,100 degrees Celsius, while its core reaches temperatures of over 15 million degrees. Every second, the Sun converts about a million tons of hydrogen into helium, releasing energy that powers all life on Earth. And yet, by cosmic standards, our Sun is completely average. It's classified as a G-type main sequence star, a yellow dwarf. There are smaller stars, yes, but there are also stars so massive, so luminous, that our Sun seems like a tiny flickering candle beside a roaring bonfire. Take, for instance, the red supergiant Betelgeuse in the constellation Orion. This star is nearing the end of its life and has swelled to an enormous size, so large that if it replaced our Sun at the centre of the solar system, its outer layers would stretch beyond the orbit of Jupiter. And then there's UY Scuti, a contender for the largest star ever discovered. It's not just hundreds or thousands of times the size of our Sun, it's nearly 1,700 times its diameter. It would take more than 9 hours for light to travel around its surface. Think about that. Light, the fastest thing in existence, would take hours just to make a loop around a single star. Size is only one dimension of a star's greatness. There's also brightness or luminosity. The brightest stars are not always the biggest. Some are incredibly compact but emit tremendous amounts of energy. Consider blue giant stars, hot, young, and wildly luminous. They burn through their fuel in just a few million years, compared to the Sun's slow, steady 10 billion year lifespan. Their brilliance can outshine an entire cluster of ordinary stars, casting their glow across great distances in space. Then there are the extremes. Neutron stars, the dense remnants of collapsed supernovae, are only a few kilometres across, but a teaspoon of their material would weigh billions of tons. They spin at incredible speeds, pulsing with electromagnetic radiation like cosmic lighthouses. Some spin hundreds of times per second, their dense matter warped by unimaginable gravity. At the very edge of stellar evolution lie black holes, where the mass of stars has collapsed into a point so dense that not even light can escape. The remnants of massive stars, they are the dark hearts of galaxies, devouring matter and warping space-time. Stars are born in cold, dark clouds of dust and gas called nebulae. Within these cosmic nurseries, gravity slowly pulls matter together until a dense core ignites with nuclear fusion. A star is born, not with a spark, but with a steady, powerful glow that may last for billions of years. Over time, depending on its mass, a star will expand into a red giant, collapse into a white dwarf, or explode in a brilliant supernova, scattering its elements into space. Those elements, carbon, nitrogen, oxygen, iron, are the seeds of life. They are the ingredients of planets, oceans, air, and blood. Everything you are made of was once inside a star. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it was forged in the heart of a long-dead sun. We are quite literally made of stardust. Stars do not exist alone. Many belong to systems of 2, 3, or more, locked in gravitational dances that can last for eons. Some orbit each other so closely that they exchange matter, feeding off one another like celestial phantoms. Others collide, sending ripples of gravitational energy through space and creating rare and exotic forms like kilonovae, violent bursts that form gold and other heavy elements. And yet, with all their power and glory, stars are just dots in the sky. To the naked eye, only a few thousand are visible at any one time. But in reality, the universe is teeming with them, trillions upon trillions, scattered across billions of galaxies. Some are already dead, their light still travelling toward us. Others are just now being born, hidden in veils of dust. The sky above us is a living archive of stellar lives, some short and furious, others slow and steady. And in between those stars is the quiet dark, a space not empty, but full of potential. There, in the silence, new stars will one day form, fueled by the ashes of the old. The cycle continues, endlessly, quietly, patiently. So tonight, when you look up, know that those twinkling lights are not just decorations. They are titanic furnaces, cosmic ancestors, distant cousins to the atoms in your body. They are reminders of just how vast and powerful the universe really is, and how deeply you're connected to it. Let your mind drift outward now. Imagine floating among the stars, not just the ones you know, but those hidden behind clouds of gas, those on the far edges of galaxies, those yet to be born. Picture their light washing over you in gentle waves. Hear the quiet hum of nuclear fusion in the distance. Feel the warmth of a million suns bathing the cosmos in soft golden fire. In the great story of the universe, stars are the beating hearts. And you are a piece of their song. When you gaze up at the night sky, you might think you're seeing the universe as it is right now. But that's not quite true. In fact, you're looking into the past. Every glimmering star, every distant galaxy, every faint flash of light from deep space is a message that has taken time to travel to you. Light doesn't arrive instantly. It moves fast, about 186,000 miles per second, but space is vast beyond comprehension. Even at that astonishing speed, light takes time to cross the cosmic distances between stars and galaxies. So when you look up, you're not seeing the universe as it is, but as it was. This is one of the most beautiful and humbling truths in astronomy. Every night sky is a time machine. Let's start with the familiar. The light from our moon takes just over 1 second to reach Earth. That means when you look at the moon, you're seeing it as it was 1 second ago. The sun is about 93 million miles away, so its light takes around 8 minutes to reach us. When you watch the sunset, you're actually witnessing the sun as it appeared 8 minutes earlier. If it were to suddenly disappear, a purely hypothetical scenario, it would keep shining in our sky for 8 full minutes before the darkness arrived. Now, extend that principle outward. The light from the nearest star system to us, Alpha Centauri, takes about 4.3 years to get here. If you see its faint glow, you're seeing it as it appeared over 4 years ago. As we travel farther into the galaxy, that time delay stretches into centuries, then millennia, then millions and billions of years. The farthest galaxies we've ever observed, captured in deep space telescope images, are so distant that their light has taken more than 14 billion years to arrive. That means we are looking at these galaxies as they existed when the universe was still in its infancy, just a few 100 million years after the Big Bang. In that light lies history. In that light lie secrets. And in that light lies a kind of cosmic intimacy, because it allows us to witness moments that have long since passed, still travelling across space, still shining. This journey of light is not just poetic, it's practical. By capturing and studying this ancient light, astronomers are able to piece together the timeline of the universe. We can observe galaxies forming, stars being born, and massive clusters of matter pulling together under the force of gravity, all by analysing light that left those events billions of years ago. We're not just seeing the universe, we're watching its story unfold in reverse, one photon at a time. Light carries information. Its colour tells us about a star's temperature. Its spectrum tells us what elements are present. Its brightness helps us gauge distance. And its redshift, the stretching of its wavelengths as it travels through expanding space, tells us how fast the source is moving away from us, helping us map the expansion of the universe itself. Some light is visible, but much of it is not. Beyond the spectrum that our eyes can see lies infrared, ultraviolet, radio waves, X-rays, and gamma rays. Telescopes that observe in these wavelengths reveal a hidden universe. Warm clouds of dust where stars are forming, supernovae exploding in high-energy bursts, black holes distorting space and time, and the microwave glow left over from the birth of everything, the cosmic microwave background radiation, which is the oldest light we can detect. It's a faint whisper from the universe's earliest moments, a glow that has travelled for nearly 13.8 billion years to reach us. And that light is still arriving. Every second, more photons from ancient stars and galaxies cross the vastness of space and touch Earth. Some fall into our telescopes. Some fall into your eyes. Without realizing it, you become a witness to ancient events, things that happened before humans walked the Earth, before Earth even existed. You are receiving signals from a universe long gone, one that changed and grew and evolved into the cosmos we see today. It is almost like a dream, isn't it? To think that the light you see now began its journey before the rise of mountains, before the oceans formed, before the first breath of life. The night sky becomes a kind of cathedral of memory, where the walls are made of light and time flows in reverse. But there's something even more remarkable. The light we send out, reflected from our planet, beamed from our spacecraft, broadcast through radio waves, also travels out into the universe. That means right now, our earliest radio signals from the 30s and 40s are moving outward in an ever-expanding bubble, travelling at the speed of light, announcing to the universe, we are here. Our presence, encoded in light and sound, is spreading across the stars. Perhaps one day, far in the future, some distant intelligence will receive a flicker of that light and wonder what kind of beings we were, what kind of world we lived on, what dreams we dreamed. In that way, we are not only receivers of ancient light, we are creators of future echoes. So as you rest tonight, think of the light that surrounds you. Light from the moon, just over a second old. Light from the stars, centuries and millennia old. Light from galaxies, billions of years in the making. Let yourself drift with it, timeless, weightless, unhurried. Imagine floating in space, your body warmed by photons that began their journey before the Earth was born. There is no rush in the universe. Light takes its time. And in doing so, it carries with it the stories of everything that has ever been. And now you are a part of that story too. The light of your life, of your thoughts and your being, will shine, however briefly, and then travel on. You too will become a whisper in the dark, a beam of light in someone else's sky, somewhere deep within the silent arms of the Milky Way, orbiting an ordinary star, spins a small, watery planet teeming with life. That's us, Earth, our home. And yet Earth is just a single grain of dust in an immense celestial landscape. When we speak of the Milky Way, we're not talking about a group of nearby stars or a constellation in the sky. We're speaking about an entire galaxy, a vast rotating disk of stars, planets, gas, dust, and dark matter so immense it stretches the imagination to its limits. The Milky Way is estimated to be around 100,000 light-years across. That means if you could ride a beam of light from one end of it to the other, travelling at 186,000 miles per second, it would still take you 100,000 years to complete the journey. And that's just the width. It's thought to be about 1,000 light-years thick in the central disk, with spiral arms that wrap around like delicate ribbons of stardust. When you look up at the night sky and see that pale, misty band stretching overhead, you're looking along the plane of the Milky Way. What you're seeing is not a single cloud of stars, but the cumulative glow of billions of suns, their light blending together into a cosmic river of light. Our solar system is nestled in a quiet region between two of the galaxy's spiral arms, in a place known as the Orion Arm. It's a relatively calm neighbourhood, far from the violent activity near the galactic core, where stars are born and die in dramatic bursts, and where a supermassive black hole, called Sagittarius A, sits at the very centre, silently shaping the movement of stars with its powerful gravity. That black hole is millions of times the mass of our Sun, and though we cannot see it directly, we can trace its presence by the way nearby stars whip around it, drawn into its invisible grip. The stars of the Milky Way are not evenly distributed. Some cluster together in dense globular clusters, ancient gatherings of stars that orbit the galaxy's core like bees around a hive. Others drift in the disk, forming spiral patterns that slowly rotate around the centre. Our Sun, along with everything in our solar system, is moving too. It orbits the centre of the galaxy at an average speed of about 514,000 miles per hour. Even at that speed, it takes about 230 million years to complete just one orbit. That means in the entire history of human civilization, tens of thousands of years, we've barely moved a fraction of the way around the galactic wheel. And while the Milky Way is our home galaxy, it is not unique. Far from it. As we look deeper into the universe, we see galaxies of all kinds, spirals, ellipticals, irregulars, each one with its own stars, its own mysteries, and its own history. But still, the Milky Way is special to us. It is our origin, our cradle, the place from which we reach out into the cosmos, sending probes and telescopes and dreams far beyond our solar system's edge. Even now, two human-made spacecraft, Voyager 1 and Voyager 2, are drifting through interstellar space, having left the protective bubble of our solar system behind. They carry with them golden records, discs etched with sounds and images from Earth, meant to communicate our existence to anyone or anything that might find them. Those spacecraft are tiny, fragile, and impossibly brave, slowly crossing the vastness between stars, still sending back whispers of data across billions of miles. And yet, despite all our progress, we've barely scratched the surface of our own galaxy. We haven't travelled to another star. We haven't sent a spacecraft beyond the very edge of our solar system. But what we have done, what makes us extraordinary, is that we've imagined it. We've mapped the galaxy not by travelling through it, but by observing it, measuring the light of stars, detecting the wobble of planets, and using the language of physics to understand the structure of something so vast we can never hold it. The Milky Way is not silent either. It hums with electromagnetic energy, bursts with gamma rays and X-rays, sings in radio waves and glows in visible and infrared light. It is alive in its own slow, majestic way, and while the stars seem still to us, they are in constant motion, forming, colliding, spinning, dying. Every star you see in the sky is part of this living organism, and you are part of it too. When you lie beneath the stars and feel small, know that your body is made of the same elements forged in the hearts of long-dead stars. You are the product of supernovae, of dust clouds, of ancient galactic cycles. You are not separate from the Milky Way. You are its child. You are a moment in its unfolding story. And perhaps that's the most profound truth of all. In this vast galaxy, where stars rise and fall, where black holes stir in darkness, where light takes thousands of years to find its way through clouds of gas, you are here, a brief spark of awareness in a swirling cosmos. You see the galaxy, you wonder about it, and in doing so, you connect with something timeless. So breathe slowly now. Imagine yourself floating in the galactic disk, weightless, surrounded by stars. Let the gentle arms of the Milky Way curl around you like the embrace of the universe itself. Let go of all urgency, all noise. Just drift. You are home in the galaxy. You are where you belong. And the stars, those ancient suns scattered through the dark, are watching over you just as they always have. In the vast stretches of the universe, between the luminous galaxies and the brilliant stars, there are regions so dark, so quiet, and so seemingly empty that they almost seem forgotten by the cosmos itself. These are the cosmic voids, enormous spaces where galaxies are few and far between, where the universe feels more like a whisper than a song. But even in this emptiness, something profound is happening. These dark places are not devoid of meaning. They are part of the very structure of everything. To truly understand the universe, we must not only explore its light, but its shadows. Void regions can span hundreds of millions of light years across. They make up the majority of the volume of the universe. If galaxies are like glowing cities scattered across a great continent, the voids are like vast deserts stretching between them, silent, still, and humbling in their enormity. They are not completely empty, of course. Even the emptiest parts of space contain a few stray atoms, a bit of light, and perhaps the invisible presence of dark matter. But compared to the rest of the cosmos, voids are astonishingly underpopulated. They are the universe's great pauses, the still spaces between the verses of a cosmic symphony. And yet, within these enormous gaps, some of the universe's most powerful phenomena exist: black holes. Black holes are among the most mysterious and extreme objects in existence. They are not just dense objects, they are the end points of matter collapsing in on itself under the pull of gravity so intense that space and time become warped beyond recognition. A black hole is a region where gravity is so strong that nothing, not even light, can escape once it crosses the event horizon, the point of no return. And yet, we can still see black holes indirectly. We can observe how they influence nearby stars, how they twist the paths of light, and how they heat up matter as it spirals toward their dark hearts. There are several kinds of black holes. Stellar mass black holes are formed when massive stars reach the end of their lives. After exhausting their nuclear fuel, these stars explode in supernovae, and the core collapses inward, compressing into a point of infinite density called a singularity. Around that point forms the event horizon, enclosing it in eternal darkness. There are likely millions of these stellar mass black holes in our galaxy alone, lurking in the dark, hidden from sight, waiting patiently for matter to fall into their grasp. But then there are the supermassive black holes, like the one that lies at the centre of the Milky Way. These giants are millions or even billions of times the mass of our Sun, and they reside at the heart of almost every galaxy we've observed. No one is quite sure how they formed. Some think they began as smaller black holes that grew by swallowing gas, dust, stars, and even other black holes over billions of years. Others believe they formed directly from enormous clouds of collapsing matter in the early universe. These supermassive black holes are not just massive, they are architects of the galaxies around them. Their immense gravity influences star formation, shapes the structure of spiral arms, and can even regulate the flow of interstellar gas. When they are active, feeding on nearby material, they become quasars, emitting dazzling jets of energy that can be seen across the universe. These cosmic lighthouses burn brighter than entire galaxies, powered by the chaos that unfolds just outside the event horizon. Yet for all their power, black holes are also incredibly serene. Once matter crosses the threshold, it disappears, its light swallowed, its path forever hidden. Time itself slows near a black hole. If you were to watch someone fall into one from a safe distance, you would see them appear to freeze at the edge, their light stretched and reddened, their motion slowing until it became imperceptible. To them, the fall would be swift, but to you, it would look like eternity. This distortion of time, known as gravitational time dilation, is not science fiction. It is the natural behaviour of space-time under extreme conditions. And yet, despite all this mystery, black holes are not the villains of the universe. They are part of its balance. They recycle matter. They shape galaxies. They may even be doorways, gateways to deeper understanding, or to other universes, or to places beyond space and time. Some theories suggest that what goes into a black hole might emerge from a white hole elsewhere. Others speak of wormholes, theoretical tunnels in space-time that could connect distant regions of the cosmos. These ideas are speculative, but they stir the imagination. They remind us that even in darkness there is potential. Even in collapse there is creation. And in between the black holes, across the voids, there is silence. A kind of cosmic silence, not made of absence, but of possibility. The universe doesn't just speak in light and sound, it also speaks in stillness. The spaces between galaxies, between stars, even between atoms, are not just empty. They are the blank pages on which the universe writes its next chapter. When you look up at the night sky and see nothing in a certain direction, you are not seeing nothing. You are seeing space. Space that holds secrets, perhaps particles we have never detected, or waves of gravity from collisions billions of years ago. You are seeing a canvas on which galaxies once formed, or might someday bloom again. You are seeing a place where the laws of nature continue their quiet work, unobserved but unbroken. And in this way, the dark parts of the universe are just as important as the bright ones. They are part of the rhythm, part of the pattern. The quiet spaces make the luminous ones shine more brightly. The stillness gives meaning to the motion. The emptiness gives weight to the wonder. So let yourself drift now, not toward a star, but into the quiet void. Let your thoughts float in that dark, gentle place between the galaxies, where time moves slowly and gravity hums a soft, low note. There is no danger here, only calm, only silence, only the ancient presence of things too vast and too deep to disturb your rest. You are safe in this stillness. You are part of it. And as the universe breathes around you, in light and in shadow, in matter and in mystery, you can close your eyes, knowing that even the dark has a purpose, and even the silence is full of meaning. From the darkness of space, if you were to rise above the universe and look down, though no such place exists, you'd begin to see an astonishing shape begin to form. Not of galaxies floating randomly, not of stars tossed like dust into nothingness, but of a structure, a pattern, a hidden architecture that spans the cosmos and connects everything in a web more intricate than anything the human hand has ever built. This is the cosmic web, and it is one of the most extraordinary revelations of modern astronomy. The cosmic web is not made of physical threads that you could touch or see with the naked eye, but its presence is undeniable. It is composed of long filaments of galaxies and dark matter stretching across the universe, intersecting at dense nodes where clusters of galaxies form, and separating vast cosmic voids, those seemingly empty expanses we've already visited in our imagination. The web is immense and elegant, a lace of stars and invisible energy, woven over billions of years. To see it is to see the universe not as chaos, but as a design, an organic dynamic system governed by gravity, dark energy, and the laws of physics. And like veins in a leaf, or neurons in a brain, the cosmic web organizes everything. It dictates how galaxies form, how matter clumps together, and even how light travels through space. At the smallest scale of the web are individual galaxies, each home to billions of stars, each rotating gently within its dark matter halo. These galaxies are strung along filaments like beads on a string, their gravity pulling them into alignment with the invisible currents of dark matter. Over time, these galaxies drift closer together, merging into larger structures known as galaxy clusters and superclusters, the densest points in the web, where thousands of galaxies orbit one another like flocks of stars. But how do we know this web exists? The answer lies in light, again, specifically in the way light from distant quasars and galaxies is absorbed as it travels through intergalactic space. Scientists have mapped these patterns of absorption, like shadows cast through fog, and discovered that the absorption lines correspond to long threads of gas and matter, the filaments of the cosmic web. Other observations, including gravitational lensing and the movement of galaxies, confirm its presence. Though mostly invisible, its fingerprints are everywhere. And what makes up this vast web? A large portion is thought to be composed of dark matter, an invisible form of mass that doesn't emit or reflect light, but exerts gravitational influence. We can't see it, but we know it's there, guiding galaxies, shaping clusters, bending the path of light. Dark matter is the scaffolding of the universe, and the cosmic web is its framework. Flowing through the filaments is also intergalactic gas, thin and diffuse, but present in vast quantities. It's the material from which galaxies are born. In some places, shock waves ripple through the filaments, heating the gas and triggering bursts of star formation. In others, galaxies fall into each other's gravity, colliding and merging to create new forms. It's important to understand that we are not separate from this web. Our own galaxy, the Milky Way, is part of a filament in the cosmic web. We are connected by gravity and motion to the Virgo supercluster, which itself is a small part of an even larger structure called Laniakea, a Hawaiian word meaning immense heaven. Laniakea contains over 100,000 galaxies, and within it, our galaxy moves slowly, like a leaf caught in the current of a great river. And this structure didn't always exist. In the beginning, after the Big Bang, the universe was hot, dense, and nearly uniform. But tiny fluctuations in the density of matter, infinitesimally small differences, began to grow under the influence of gravity. Over billions of years, those differences became rivers of matter. Those rivers became filaments. And those filaments became the skeleton of the universe we know today. The web grew gradually, silently, shaped by forces we are only beginning to understand. In a sense, the cosmic web is a kind of map, not just of where galaxies are, but of where they are going. Like trails in a forest, it shows the paths along which matter flows. It tells us that the universe is not random, but structured, evolving, alive. And it humbles us too, because for all our achievements, we are so small. Our entire galaxy is just one speck clinging to one filament in a web that spans billions of light years in every direction. And yet, within that web, life emerged. On a quiet little planet, in the outskirts of a quiet little galaxy, consciousness arose. And from that consciousness came wonder, curiosity, the urge to explore, to understand, to belong. That urge led us to telescopes, to mathematics, to satellites, to dreams of stars. And in those dreams, we discovered the web, the silent, glowing lattice that binds the universe together like a heartbeat binds a living being. There is something profoundly poetic in this. The same patterns we see in the brain, the same branching networks of neurons, the same clusters and connections, we see in the cosmos. The universe is not just around us, it is within us. The web that stretches across the sky also stretches through our minds. So tonight, let yourself imagine the web, not as something cold or abstract, but as something soft and luminous, like strands of silk floating in space. Picture galaxies moving slowly along these threads drawn by gravity's hand. Picture the Earth and your body and your breath all suspended within that same structure. You are not alone in the universe. You are connected. You are held. In the silence of space, where no voice can speak and no foot can step, the cosmic web sings a wordless song. It is the architecture of everything, the shape of the stars, the path of time, the breath of galaxies. And as you drift into sleep, know that you are not falling into darkness, but into a place of connection, of depth, of cosmic belonging. The web is all around you. And it is beautiful. There's a question that lingers at the edge of human understanding, so vast and profound that it can quiet even the loudest thoughts. Could the universe be infinite? It's a question that scientists, philosophers, poets and dreamers have all wrestled with for centuries. And while we can observe only a limited portion of the cosmos, the so-called observable universe, we have every reason to believe that beyond that lies more. Perhaps much more. Perhaps an endless expanse with no edge, no centre, and no boundary at all. If the universe is indeed infinite, then there is no outer wall, no final star, no cosmic curtain hiding a backdrop of nothingness. Instead, space just continues, quietly, patiently, eternally. The galaxies don't stop at the edge of our telescopes. They keep going, scattered across the fabric of space like grains of sand on an infinite beach. And if space is infinite, then something strange begins to happen. The rules of probability start to take over. In an infinite universe, every possible arrangement of matter that can happen must happen somewhere. There could be another planet like Earth, with another you, reading these very words, under a sky just a little different. This isn't fantasy. It's a natural consequence of endless possibilities within endless space. The atoms that make up your body could rearrange elsewhere in another corner of the universe into a perfect copy of you, or an almost you, or a version so different it barely resembles anything familiar. But while that can stir the imagination, infinity also humbles. It reminds us that we will never reach the end. No spacecraft will fly to the edge of the universe, because the edge doesn't exist. Like walking across the surface of a perfect sphere, no matter how far you go, there is always more ahead. The universe folds back on itself, or stretches out forever. It may be curved or flat, or something our minds can't yet grasp. The truth is, we don't know for certain, and perhaps we never will. Our tools, our telescopes, our mathematics, brilliant though they are, can only reach so far. Beyond that, we rely on inference, theory, imagination. The idea of an infinite universe is one of the most extraordinary and peaceful concepts we can hold, that existence has no limit, that we are floating in a sea without shores, that no matter how far we dream, the cosmos can hold it. So as you lie in stillness, let that idea expand gently in your mind. Picture the stars not as scattered lights, but as endless fields stretching into a horizonless night. Picture galaxies like blossoms, blooming forever into the void. There is no end. There is only more. And you, a single soul resting within it, are part of that quiet eternity. In the heart of all this cosmic grandeur, with its spiraling galaxies and infinite expanses, there sits something incredibly tender, the fragile reality of your own existence. We often talk about how small we are in the universe, how insignificant we seem. But what if that smallness is not something to fear, but something to embrace? You see, for all the enormity around us, our little corner of the universe is quiet, safe. Earth orbits a stable star within a relatively calm region of our galaxy. No black holes threaten us from nearby. No star is on the verge of exploding dangerously close. Our solar system is not hurtling through a dense cluster of galaxies or gas clouds. It's drifting, slowly, peacefully, within the spiral arms of the Milky Way. It's this quiet that has allowed life to flourish. It's this stillness that has made room for complexity, for evolution, for thought, and for beauty. This quiet place in the vastness has become home to oceans, forests, cities, and music, to stories and memories, to moments of love and loss. It has given rise to creatures that look at the stars and wonder what lies beyond. And maybe, just maybe, that's not an accident. Maybe the universe, in all its enormity, makes space for smallness, for gentleness, for the delicate bloom of consciousness. Maybe the same laws that shape galaxies also carve out little eddies of calm, places where dust can gather into planets, where molecules can assemble into cells, where dreams can take root. In the cosmic silence, Earth is like a warm hearth glowing in the night. It is one of perhaps countless homes, but it is ours. A place where you can rest your head, close your eyes, and feel the ground beneath you holding you up, not just physically, but spiritually. A place where the stars are not just lights, but companions, guides, reminders. So tonight, as you drift off, imagine your place in this quiet. You are not lost in space. You are resting in a calm pocket of the cosmos. The universe, vast as it is, has made room for you. And in that room, you're free to think, to feel, to sleep, and to simply be. And now, as our journey comes to its final chapter, we return to where we began, beneath the stars. Perhaps you're already halfway to sleep. Perhaps your mind is floating, weightless, drifting among the planets and galaxies we've visited. Let's take one last moment to let it all settle. Tonight, you've travelled further than most people ever will, not across land or sea, but through time and space and possibility. You've floated beside stars 1,000 times the size of our sun. You've stood at the edge of the observable universe and looked beyond. You've wandered through cosmic voids and traced the filaments of the cosmic web. You've thought about infinities, about the light from ancient galaxies, about black holes that swallow time itself. And through it all, you've been wrapped in silence, in slowness, in stillness. That's the gift of the universe. It doesn't rush, it doesn't demand, it simply is, and it invites you to be too. So let yourself fall into that rhythm now. Let the worries of the day fall away like stardust drifting through the dark. Let the questions fade. There is nothing to solve here. There is only rest. You don't have to think anymore. You don't have to understand. The stars will keep spinning. The galaxies will keep drifting. The light will keep moving through space. You are part of all of it. A piece of the story. A thread in the web. a spark of awareness in a sea of time. Let that be enough. Sleep now, beneath the stars, within the galaxy, under the great silent dome of the universe. Let the cosmos hold you. Let the night carry you. Let the infinite expand, and let your breath slow with it. You are safe here. You are home.